So I'm here today to discuss about privacy and how to balance privacy and accountability in identity systems. So I'm Christian from Microsoft Research, and these are the things we're going to discuss today. So first, a little bit about motivation, and then we're going to introduce a privacy-enhancing cryptographic technology that we call minimal disclosure technology, and one in particular that we developed at Microsoft called uProof. And I'm going to describe a couple of projects in which we're involved that use that technology. It's a new feature we built, which is released, and then I'll show a live demo. So first, just about talking about some motivation. So of course, we'll have to justify the fact that we want to, in this online world, as we transition a lot of transactions from the offline world to the online world, we want to preserve the security that we have there. We want to renew, for example, your passports. You have to go to an office and show who you are, or renew your driver's license. You could go there in person. It costs a lot of money. So what does it mean to move these transactions online? So we have to have a very high level of assurance about the person that wants to do this transaction. Of course, because of the rise of identity theft and all these things, we want very strong security. But there's also a strong need to preserve the privacy, and it's a rising concern by many stakeholders in these debates. And it's not that they want to be fully anonymous, but what the goal is to preserve the autonomy and the privacy that you have in the offline world. So when I go into a bar to buy some wine, presenting my driver's license, can show that my date of birth. The clerk can verify that I'm over 21. Gets to see all the other information, my name, address, date of birth, but his brain is not connected to a backend system that doesn't get recorded forever, and the government doesn't get notified that I just walked in this bar to present that credential. This is pretty offline, peer-to-peer transaction. But the current identity systems that we have today, the PKI or Federation protocols, have a lot more inescapable tracking capabilities that are built in. Sometimes by design, sometimes it's just a byproduct of the technologies they use, and that might lead to some unwanted consequences down in the future. So what we want to do is try to change how these schemes work and provide better privacy protections from the get-go rather than trying to deal with these privacy problems later. A good example of that is the National Strategy for Trusted Identity in Cyberspace, the NSTIC program. There was a panel earlier today to discuss that, and it's kind of a call to action from the government to the industry. And what's interesting is they do say, yeah, we need very high level of security, but we also need very high levels of privacy. So the requirements are kind of becoming more present in these systems. I mentioned PKI and Federation protocols. And PKI is very well known, of course, and it's a way to bind attributes and also a key pair to a person with a digital certificate. And it can contain attributes of any types using the extensions built in the framework. But when you want to present, for example, the equivalent of your driver's license, if it was encoded in an online certificate to an online casino to prove that you're over 21, well, you cannot only show date of birth, you have to show everything, right? You have to show my name, address, everything that's in there. And even if the certificate would not identify me, if it would just contain, yes, a statement that says, yes, the owner of that certificate is over 21, the public key in there and the signature of the issuer are unique numbers. It's essentially they're even contain more uniqueness than social security numbers, but it's inescapable unique number that's attached to me. So if I reuse it across multiple websites or over time, some of the relying parties can build a dossier on me, which is maybe not what the best thing to do in identity systems. And on the counterpart, the federated protocols, be it WS Trust, SAML, Facebook Connect, OpenID, OAuth, all these frameworks have a different mode of operation. So instead of getting a certificate or some credential in advance, I do visit a relying party that says I need to see these claims about you to prove that you're of age, and then I can be redirected to an identity provider that can provide this proof. For example, my bank or my school, I authenticate there because I have an account relationship with that identity provider. I get back a signed statement, and then I present it to the relying party. But the problem is that this identity provider has a lot of visibility about all my online activities, and furthermore can also impersonate me because the token that I present typically doesn't have a private key associated with it. It's just a bearer token that I just relay from point A to point B. So there are multiple attacks that are possible in this system. So there's, since the early 90s, there was a new class of cryptographic technologies that have been proposed. These were called, known by different names. I like to call them minimal disclosure technologies. Another name also is anonymous credential or attribute-based credentials, sometimes with privacy features. So what it is essentially a superset of the functionality of PKI, public cryptography, but with two main differences. Difference number one is that the way these certificates are issued, the signature, instead of using conventional RSA or DSA signature, they are signed using what's called blind signature. And it involves randomization by the user. So the resulting signature in public key, it's a random string of bits, but it has never been seen by the issuer because the user can flip a few coins before they were issued. It's a multi-party computation. Therefore, when I present it to a relying party, I can go back to the issuer and say, I received a certificate from you, from one of your users, and you tell me which one it was. I said, no, I cannot because I've never seen that actual public key. It's been randomized in the process. So it breaks the linkage, it breaks the linkability between the issuance and the presentation. And also the second difference is that what you can do with the attributes encoded in that certificate. So instead of just presenting it and showing everything that's in there, I can prove properties of what's encoded in there. I'll give an example to illustrate that in a few seconds. It's going to be clear. And they've been proposed to use, they were, in the early 90s, they were proposed to do eCash. Actually, mid-80s, even David Chow was the first inventor of such a system and proposed to do eCash with these tokens. But eCash didn't really go anywhere. All the e-payments today are credit card based, essentially, except Bitcoin, which kind of just recently got more popular. But now these technologies are being used for all sorts of things, to the electronic credentials in general, like the ones that are illustrated here on the slide. And the two main ones that are popular is that some maturity is one that you group that we developed, and the one called Identix from IBM. So just to illustrate what I mean by minimal disclosure, so imagine this little scenario where you have a student just from school and she wants to access an e-library. And there's this deal between the school and the e-library, could be Amazon or anything, where users, students from a certain type of program can access this library. Right? So Alice can go to the school, download this credential that states her name, address, her program, gets encoded in this credential, and you can think of it as just being issued a certificate. It corresponds to a private key only known to Alice in this case. And then when later, if she wants to go to the relying party, the e-library, ask, you have to prove that you're a graduate from the state of Washington, because that's the deal we have with, for example, all the universities from that state. Well, Alice can take her credential and hide completely all the attributes that she doesn't need to see. Only show that she's from Washington, and not even show her actual program, which can prove that it's part of a set of acceptable programs. Just show that she's from a graduate degree, and then be able to present that information. So if you know how PKI works and how digital signature works, that should be a bit counterintuitive. Because typically, if I have a signed document and I remove parts of it, the signature should become invalid. Well, so that's how normal signatures work, but blind signatures work a bit differently. I can actually only show a subset of the attributes that were signed and still remain the validity of the signature. If you know what a hash tree is, I mean, it's a bit the same concept. I'm just giving signed leaves and I can remove some leaves of the tree and it'll still arrive at a signed root that's been validated by the issuer. And now, so that was this minimal disclosure aspect, and the unlinkable aspect is now if the e-library goes back to the issuer asking which student was that, it's one of your certificate. The school has no way to figure that out. There's even an insider sitting, malicious insider, and the school has no way to track and trace its users. So again, there's a long history of this technology. The one in particular that we're working on called uProof, it's been developed. As I mentioned, in the early 90s, Microsoft released the specifications publicly a couple of years ago, submitted specs to ISO, working group dealing with client signatures, open source SDK that we've published also. But now what I want to present is some new accountability features that we developed recently in the last year. David, which in his keynote this morning, made an interesting point when there was a question about should DCG consider a bit more some anonymity use cases and scenarios to use DPM to attest that I'm a DPM, but I'm revealing a particular identifier for a user. And he mentioned, yeah, anonymity is good, but anonymity without accountability is not very useful. And I think it's a good point to make that in order for these type of technologies to provide their privacy benefits to be able to be usable in real-life scenarios, we need the accountability mechanisms that we're expected to have in identity systems. That's what I'm going to present. And mainly what I'm keep the suspense for a little while about the new features that we're going to introduce. Just to represent how you can integrate this type of technology like uProof within conventional federation scenario. You can think SAML or VBS Trust here. So instead of getting my token on demand when I'm visiting a relying party, because of the minimal disclosure capabilities, I can get them in advance, just like in PKI. And as long as the relying party trusts the identity provider the same way relying party trusts CA, because they have their certificate, Alice can get her token in advance, and then later present one particular token with the minimal set of data that's required for this particular transaction to respond dynamically to the policy that's being requested. All right. I'm going to present a few projects that we've been involved with, and some of them are currently running. This is a project we did 3 years ago with the German EID card. As you may know, in Germany they have an identity card, national ID card, and there's actually, it's quite good around the privacy protections they have there. It's a very strict policy of who can carry the card, and they all have this concept of minimal disclosure, only presenting a subset of the attributes that are requested by an authorized party. But we did a little proof of concept with Franacher Focus to, those are great protections, but it's quite limiting. You cannot just take your ID card and present it to Amazon to get some rebates or to prove attributes about yourself or to any identity provider or relying parties. So what we did is we transformed the attributes that were on the card into uProof tokens, and preserving the security and privacy offered by the card, and able to extend its reach essentially to all sorts of ad hoc websites on the internet. And we did kind of an ebook demo with that. So it's an interesting way to bootstrap a very strong and secure credential and be able to use it in a more flexible manner online. Some details of this URL, and I encourage you to look later. So another important project that we are part of is a European project. It's funded by the government. It's called Agency for Trust. In essence, it's a little bit similar to NSTIC in nature, what it's trying to achieve, but in Europe, but a bit more academic rather versus industry like NSTIC is. But the goal is essentially to list and compare all sorts of technologies, minimal disclosure technologies, and implement them, build a common abstraction layer on top of them, and also pilot them. So there are 2 pilots that are underway. We're participating in this consortium along with our technology partner at IBM, and all sorts of other companies that are listed in this list. And this project is going on. I encourage you to learn more about it by visiting this website, abcfortrust.eu. And we're now in the 3rd year running the pilots, and the 4th year will be dissemination. So I guess we could add a little more papers and results to show in that last year. So the 3rd and last project I'm going to talk about now is the one in our NSTIC project. So it's one of the pilots that was funded last year. It was known as the ANVA pilot. The official name is Cross-Sector Digital Identity Initiative Pilot. There's a bunch of companies involved in organizations, including ANVA, which is the American Association of Motor Vehicle Administrators. Essentially, it's a group of all the DMVs and DOLs in the country. And because it's recognized, so there was this discussion earlier today, so we're missing relying parties. We're missing, if we have strong identities, we need some place where we can show it for it to be useful. Like one of the goals is bringing a higher level of identity online is to be able to take some of the transactions that we do offline in buildings and with people that are expensive for the buying the buildings and paying the people to do these things. If we can reduce the costs of business and the government to do it online. So, this pilot is trying to achieve that, to be able to take some of the attributes that are, for example, known to the DMV, and be able to get it to the user in a form that's usable to access some other government resources while providing very strong privacy and security guarantees. So there's another URL that you're welcome to take a look at to learn more about this project. Okay, so now I'd like to talk to you about the accountability measures that we recently worked on. So it's great to have strong privacy benefits, and at times being fully anonymous makes sense, like in the voting scenario or in free speech or reviews or to fill some surveys where I want to be guaranteed that my boss will have access to the comments I'm making on the organization. So full anonymity or certified anonymity that yes, this person was really in that group and therefore is allowed to make these comments is one thing. In other cases, you want to be fully identified when you access your bank account. I mean, I don't expect to be private versus the bank. On the contrary, I want to make sure they know it's me and not somebody else that can access my account. But in between, there's also all sorts of use cases where you want pseudonymity. But when you are not identified, there's always some measures that will increase security and the trust that you have in the transaction. So I'm going to present 3 of them. So the first one is how to bind these online tokens to a trusted hardware or a second factor. And I'm going to use a phone as an example. Second one is an ID escrow scheme where it's a way to be fully anonymous in a transaction, but if something goes wrong and I don't respect the terms and service of the service, or I committed a crime or something that's illegal, then there's a way for an authorized party, which could be law enforcement or the administrator of the site, if they haven't proved that I did that, they can figure out why and decrypt my identity that was not disclosed. And the last one is a way to provide revocation, like we have in PKI, to be able to do revocation when I'm not disclosing my identity. All right, so the first one, and I'm going to use, as I mentioned, the phone as an example of a second factor. So everybody has a phone nowadays. believe it's going to be the next wallet in a couple of years. Nobody will carry wallets anymore. It's a great form factor to carry your secrets on. But now, the question is, can we make it secure? So what we did is to be able to use these online tokens, the Federation tokens, which are error only, and be able to split its private key in two. So one is handled by the system, the browser, or whatever component is interacting with the website that you're presenting a credential to, but also tied to a device. And in order to unlock the token presented, I have to query and give a cryptographic challenge to the phone. And we've implemented in prototype 2 ways to do that. One with NFC, near-field communication, where this laptop I can just tap my phone to have this conversation, and then it just works. And the second one is through push notification, where my phone is registered with a service, and then when my client needs to invoke the phone, it just sends a message, it gets pushed to my phone, and then I can authorize the transaction and send it back. So it might look familiar because there's a lot of applications that do that already through just SMS confirming that you own the phone number, but hacking the phone system it's not easy, but it's feasible. It's easy to hijack somebody else's phone number and get calls redirected to you. So if you have this capability, then you can defeat the second factor. But if you actually need the phone to answer a cryptographic challenge with a key that's only on the phone, then that becomes feasible to hijack somebody else's second factor. So we did that, and the good news is we can actually use the TPM to do so. So this key splitting technique is actually quite general. The phone now, out of the box, current OS, it's a Windows phone, doesn't allow you to access this TPM at this level, so we have to modify the OS to do so in our prototype. But hopefully in the future we'll be able to do it. Is to use commit and sign features of the phone, of the TPM, to be able to encode that. So I will not bore you with the math details of that, but we also have on the website that I'll refer at the end of the deck more details about that. So if you want more details, feel free to ask me or go look at the white paper. The second mechanism that we're going to talk about is the ID escrow scheme that we developed. So as I mentioned, presenting a liquid token is like presenting a certificate or my driver's license and have a black marker pen that I can apply and remove everything that I don't want to show, which could be my name. But an auditor, if I commit a crime, might decide I need to see that information. So you might insist to have a way to be able to lift the anonymity of a transaction. So how we do that is, instead of taking a black marker and not disclosing your name, what you're going to do is the user has the ability to encrypt it, place it in an encrypted form, and give it to the relying party. The relying party will not be able to see this information, but as a way to verify that it's correct, that it not just encrypt some junk that will be decrypted to nothing later by an auditor, that the relying party can verify that I actually did correctly encrypted my name and not something else. And then an auditor can later decrypt this when it is authorized. Of course, any escrow scheme can be easily critiqued by the privacy community, and it needs to be designed with care because you don't want simply bad people to just have access to the description key and just be able to lift the identity of all the users. So the best way to deploy such a mechanism would be to do some key splitting. Could be by law enforcement and a privacy community group, and when there's a court order, it could be a system to reconcile the key and be able to decrypt the identity of a particular user. And one more interesting thing is that the terms under which the key could be decrypted can also be signed by the user. So the term of service, when they can be presented to the user, or some auditor on behalf of users, and say these are the terms, and if you don't follow them, then we'll be able to decrypt who you are. And the relying party is then able to change the terms afterwards and accuse the user of doing something that he did not. One example of where that could be interesting is Wikipedia does not allow anonymous users to edit some content. You can, and one thing they don't allow, for example, is to come from Tor, or is the anonymous browsing mechanism that allows you to hide your IP address when you go to a website. So, what you might imagine, it could be interesting in some people to authorize certified or experts that want to edit some pages but don't want to reveal their identity. Chinese dissident, or you can imagine many scenarios. So it would be nice to have a way to allow to accredit people, verify their background. So yeah, you're an authorized author in this field, and you can edit and log in with the real pseudonym for which you maintain full anonymity. And then if there's not a jury, but a committee that decides that what you wrote is not following the terms that Wikipedia says, or that they presented to you when you got the certificate, then they could revoke your identity. And it would be beneficial to a set of users that would choose to remain anonymous, and would allow the bad guys to be caught and de-anonymized. Okay. Last but not least, the last feature is user revocation. So of course, PKI has revocation built in. Every certificate has a serial number, and if you present a certificate, if the serial number is on the CRL, the certificate revocation list, then you're not allowed to access whatever system you're trying to access. It's quite easy to build a revocation system where you're disclosing a unique number every time. Right? That's built in PKI. Of course, when by design we're trying to remove these unique identifiers in these type of systems, it becomes quite difficult to build revocation. So what we can do instead is, instead of having the relying party verify on the back end that your serial number is not on the list, we can have the user prove proactively that she's not on the list without disclosing her identifier. So one example where that could be useful is the no-fly list, right? Everybody needs to identify themselves to go on a plane nowadays. And one reason is to verify that you're not on the no-fly list. So what we could do is instead taking our passport or our ID document, just magically wave it on top of the list and say, yeah, I can make a proof that I'm not on the list without actually disclosing my name. So that's possible with this type of system. And then if the list gets updated and I come back next week, then I'm not able to make that proof anymore if I've been revoked. Okay, so these are details. I'm going to illustrate that now with the demo I'll present. And the scenario is as follows. I'm going to build a privacy-respecting marketplace where users can go and buy games and apps and all sorts of things. But instead of her credit card being charged every time she makes a purchase, she's going to instead, in advance, purchase a bunch of anonymous tokens. And then later, when she gets some games or songs, she just spends these tokens. And if she hacks the system, try to reuse a token, it's like a coin. You're supposed to, the system or application would delete it every time if she tries to reuse one maliciously. She will be detected, and then her identity will be decrypted, and she'll be put on the revocation list, and therefore all her other tokens will become invalid. So that's the scenario I'm going to present. Quickly, it's a live demo, so hopefully it's going to work. Directly from Visual Studio. There you go. So I have some consoles here from the issuer. I have two relying parties, Paquin and Cryptoso, and an app running on my laptop. I'm not going to show, we built also the second factor with the phone, but because of my setup on my local laptop here, I'm not able to access the phone, so skip that part. So to enable the system, the user goes to manage her account, and then she can purchase some tokens in advance. Oh, you don't see anything. I'm the only one seeing that. So, there's a little app, and she can purchase some tokens. It's preset. So I've been charged in advance to buy 8 tokens. Great. So now the user can go and decide to buy some music. And just spend the token. And now, you can play it. Good words. Alright, so what happens now, I spent the token. The issuer, the marketplace, doesn't know which line party I visited or even what song I bought if they knew it would go there. The Contoso Music website here just receives a valid token. It knows it came from the marketplace. They can send back to the marketplace to get back their money. They don't know which user visited, so it's fully anonymous. But now I have a little hack simulation. So let's say the user is trying to cheat. The system now deletes the tokens as they are spent, but we have a hack mode that I just enabled, which as if the user hacked the software to not delete the token and reuse them. So if the user wants to buy this game, it's going to spend the token, it's going to work, but will not delete it. So now if I try to buy something else, I'm going to reuse the same token. But now something is going to happen. It won't work. Because what's happening under the cover is that I've sent to the website the token that's already been spent by the system. The system will be reconciled. So I've already seen that public key. So it's an unlinkable public key. It cannot be tied with the issuer, with the original user, but it's the same one. I've just seen it. So what I can do is now, every time the ID escrow system was enabled in the system, so along with presenting this anonymous token, the user also encrypted her identity with it. So this transcript was sent to the auditor, which was able to decrypt it and figure out that it was Alice. And that's sent back to the issuer. It's going to put Alice's identity on the blacklist. So now, this particular purchase didn't work. That's fine. But what we've effectively done now is revoke Alice from the system. So she has still 6 tokens that are valid, otherwise valid, and we're going to stop the hack mode. So she uses a new, fresh token that's totally unlinkable. But because her identity, the Alice account name, is in the token, and that Alice is now blacklisted, listed in the blacklist, she's not able to prove that she's not on the blacklist because she is. So she will not be able to access the system a second time. And the reason for that is that she's not able to pass the non-revocation proof. So that's just a little illustration that these technologies are very practical. They've been researched for many years, since the mid-80s, 90s, and now we're getting in a kind of research pilot to real-life industry pilot, like the NSTIC pilot that we're part of. So they're emerging, and they provide very strong privacy capabilities, but they're fully protecting the privacy of its users while providing what system designers want, the accountability features to be able to detect and ban and revoke fraudulent users. So that concludes my presentation. the end. All the details, there was a page before that with some resources. If you want to learn more about that, it's a very simple link, microsoft.com/uproof. I'm part of the XEG lab at Microsoft Research. We have some more details over there. And if you have any questions now or later, you have my email address there. And feedback and comment is always welcome. So I thank you, and a few minutes for questions.
So I think it's a great overview. So you said it's part of research and ongoing industry, cross-industry associations and things. That's great. So what's the roadmap? I'm thinking, how do we benefit from this?
So, all the technology is available. As I mentioned, we have open source SDKs, and the spec have been published and contributed to ISO, so it's ready. The privacy features, I would say, are pretty recent. In identity, I've been in this identity space for more than a decade, and security requirements always overshadow any hope of any privacy requirements. And now, in Europe, it was more present, but now in the US, since the NSTIC vision document came out with more privacy-preserving requirements in it, then there's been a resurgence in interest for these type of technologies. So I think right now we're at a stage of trying it out, pilots. So pilots opportunities, and the technologists have been playing with these type of things. So we did some of the projects that just to showcase. We have collaboration with Gemalto. We did build the protocol there, some smart cards. And one of the demo I did not show here, and with all sorts of partners. So it's there. So after the pilots, and of course, we're following the pilots. We'll see what interest is in the results of these pilots, and if people want it, we can make it available in a broader manner. But yeah. All right. So thank you for your attention, and have a great end of the conference.